In physics, there is one idea that's keep coming back, no matter how many times we think we escaped it. An idea so strange that even Einstein would have raised an eyebrow. It sounds like science fiction. It feels impossible. Yet some of the most respected physicists on Earth treat it as a serious, legitimate possibility. The idea is simple and terrifying. What if the universe is a hologram? Not a computer simulation, not a projection from some alien machine, but a cosmos where everything we experience in 3 dimensions is actually encoded on a distant 2-dimensional surface. Every star, galaxy, every atom, even us. It sounds absurd, but the more we study black holes, quantum information, and the geometry of space-time, the harder it becomes to avoid this conclusion. And here is the unsettling part. When you look at the math, the equations, and the limits of information, the universe behaves exactly like a hologram should. So if this idea is wrong, the universe is doing a very good job pretending otherwise. If the universe really is a hologram, there has to be a reason. Some clue, some physical law pointing in that direction. And strangely enough, the first hint came from the most violent objects in existence: black holes. For decades, physicists believed black holes were simple, regions of space so dense that not even light can escape. No hair, no details, no information, just a cosmic drain where everything falls in and nothing ever comes out. But that created a massive problem. According to quantum mechanics, information can never be destroyed. It can change form, it can scramble, it can hide, but it cannot vanish. Black holes look like nature's shredder, objects that ate the universe and erased its history. Then Jacob Bekenstein and Stephen Hawking discovered something that flipped physics upside down. They found that a black hole's information content and its entropy doesn't scale with its volume, but with its surface. Think about that. A 3-dimensional object storing information on its 2-dimensional surface. A perfect match for a hologram. This is where things get weird. If black holes store information on their surface, what about the universe itself? What if the cosmos is just the biggest black hole of them all, or at least governed by the same rules? And this is where the holographic principle begins its rise from fringe idea to serious contender. By the way, if you enjoy deep dives into cosmic enigmas like this, mysteries that bend physics and force us to rethink reality, make sure you subscribe. These videos take time, research, and a slightly unhealthy obsession with the universe, and your support really helps push the channel forward. Now back to the paradox, because once you accept that information is written on the skin of a black hole, you stumble into a next unavoidable question. Is the universe storing its information the same way? And if it is, then everything we see inside might not be the true fundamental reality at all. It might be something projected from elsewhere, encoded on a vast cosmic boundary we can never reach. So, if black holes store their information on a 2-dimensional surface, what about everything else? This is where the idea stops being a curiosity and starts becoming a genuine threat to our understanding of reality. Because the more physicists studied the black hole paradox, the more one thing became clear. Nature seems to prefer storing information on surfaces, not volumes. A strange preference for a universe that looks overwhelmingly 3-dimensional. And that brings us to the holographic principle. The basic idea is deceptively simple. Everything that happens inside the region of space, every particle, every field, every fluctuation, can be fully described by information encoded on that region's boundary. In other words, the real physics might live on a thin cosmic shell, while the 3D universe we experience is the emergent picture inside. Like the hologram on your credit card. The real pattern is flat. The 3D image is the illusion. Now, this doesn't mean we are living in a cheap sci-fi projection. This is not the Matrix, not an alien projector, no cosmic cinema. It means that 3-dimensional reality might not be fundamental. It might be a higher dimensional expression of lower dimensional information. And here comes the curiosity reset, because there is one question you might already be asking. If the universe is a hologram, where is the surface? That's the mysterious part. Some physicists argue that the boundary is the cosmic horizon, the limit of our observable universe. Others suggest it exists in a mathematical space we can't access, a kind of an abstract boundary in a higher dimensional geometry. and others think the boundary is not a physical thing at all, but a deep relationship between quantum information and gravity. Whatever it is, the principle is the same. Reality, as we see it, may be a shadow of something deeper. For years, the hologram idea existed as a strange possibility. Interesting, elegant, but far from proven. Most physicists treated it like a clever mathematical curiosity. Something fun to think about, but not something you build a universe from. And then came Juan Maldacena. In 1997, Maldacena published a paper that quietly detonated across theoretical physics. He showed something extraordinary. A complete universe with gravity could be perfectly described by a completely different universe without gravity, living on its boundary. A three-dimensional world mapped to a two-dimensional one. A cosmos inside, an equation outside. One reality projected from another. Physicists call it the ADS-CFT correspondence. It became the first mathematical evidence that the holographic principle might not just be an idea, but a deeper truth about the structure of reality. To be clear, Maldacena's universe was not ours. It was an anti-de Sitter space, curved inward, not outward. A mathematical playground, not a physical copy of the cosmos we live in. But the implications were impossible to ignore. If the correspondence works in one universe, even a hypothetical one, then the framework might be universal. Gravity and quantum mechanics, the two great rivals of physics, suddenly look like two sides of the same holographic coin. This triggered an avalanche of research. String theorists found new ways to connect geometry and information. Quantum gravity researchers found that spacetime itself might be a product of entanglement, not a fundamental ingredient. And cosmologists began wondering if our universe, vast, expanding, and full of mysteries, might have a holographic description too. Because if spacetime is not fundamental, if it emerges from entanglement patterns written on a boundary, then the universe we see is not the universe that is doing the computing. Reality would have layers, and we are living in a projection, not the source. But does any of this apply to the real world? Or is this just beautiful mathematics living in its own dimension? To answer that, we need to look at something we can actually observe. Something real. Something etched across the entire sky. If the hologram idea is more than mathematics, then it should leave fingerprints in real universe. Not predictions you need a particle collider the size of Saturn to test, but clues written in the sky itself. And believe it or not, physicists actually found few places to look. The first one is the cosmic microwave background, the oldest light in the universe. An almost 14 billion year old snapshot of what the cosmos looked like when it was only 380,000 years old. If the universe has a holographic origin, some models predict tiny deviations in the CMB's temperature fluctuations. Not random noise, not errors, patterns that hint at information being encoded on a boundary. Some analyses have found faint signatures that might match these models. Not proof, not confirmation, but enough to keep the conversation alive. Then there is quantum entanglement. This might be the strangest clue of them all. Several physicists have shown that the geometry of space-time, the smooth shape of the universe, could emerge from entanglement patterns, meaning the distance between 2 points in space might not be physical, but informational. The universe would not be built from particles or fields, but from relationships. And here is the wild part. If you remove the entanglement between two regions, the geometry between them literally breaks apart in the equations. Space stops being space. This is exactly what a holographic universe would do. Now add the black hole information paradox back into the mix. If the information is encoded on surfaces, not volumes, and if spacetime is built from entanglement, and if the CMB shows hints of boundary-like behavior, then the holographic principle is no longer a strange theory sitting on dusty chalkboard. It becomes a framework, one that ties quantum mechanics, gravity, and cosmology together. So if the universe is a hologram, then everything we know, planets, stars, galaxies, spacetime itself, is not the deepest layer of reality. It's only the code. And if the holographic principle is true, even partly true, then we need to rethink what we mean by reality. Because a holographic universe is not fake, it's not simulated, it's not imaginary, it's simply deeper than the world we experience. In this picture, spacetime is not a stage the universe performs on. It's something that emerges from information, the same way a three-dimensional hologram emerges from a two-dimensional pattern. What we call matter becomes excitations in that information. What we call gravity becomes the bending of the encoded geometry. And what we call distance becomes a measure of entanglement, not space itself. It means the universe we move through, the one we see and touch, is only one layer of a much larger structure. A good analogy is a shadow. The shadow is real. It has form. You can measure it, but it's not the thing casting it. If the holographic principle describes our world, then everything we see is the shadow reality, the image, the projection, the expression of something happening elsewhere on a boundary we can never reach, written in a language we are only beginning to understand. And here is the question that stops everyone for a moment. If our universe is the projection, what is the thing doing the projecting? When scientists talk about the holographic principle, it's easy to misunderstand what they mean. We are not saying the world is fake, or that nothing is real, or that we are trapped inside a simulation. What the holographic principle suggests is far more interesting. The reality is deeper and more layered than we ever imagined. Every discovery made about the universe pushed us further away from simple explanations. The Earth was not the center. The galaxy was not the entire cosmos. The universe itself is not as straightforward as it looks. And now we may be discovering that the dimensions we live in are not fundamental. If this theory is true, then our universe is the visible side of a hidden structure. A vast cosmic boundary holds the information that gives rise to stars, galaxies, and life. We are the expression of something greater, not less real, but part of a deeper reality that we are only beginning to glimpse. And the strange thing is, the more we learn, the more the universe becomes both familiar and impossible at the same time. Thank you for watching. Keep looking up.